China unveils ambitious blueprint for next-generation supersonic jet to outpace Concorde by 2025. Date: March 31, 2025. Source: Comac Science. Yahoo News. Interesting engineering. Introduction. In a groundbreaking move for the aviation industry, China's state-owned aerospace manufacturer Comac has announced its ambitious plans for a next-generation supersonic jet, the C949. Scheduled for introduction by 2025, this state-of-the-art aircraft is designed to exceed the performance benchmarks set by the iconic Concorde, which retired in 2003 due to concerns over noise pollution and safety. Key features of C949. 1. Speed and range. The C949 is engineered to reach speeds of up to 1.6 Mach, which, while slower than the Concorde's Mach 2.2, offers a substantial increase in range. It can cover distances of up to 11,000 kilometers, approximately 6,800 miles, representing a 50% enhancement over the Concorde's maximum range of 4,500 miles. This capability will allow for non-stop flights from locations such as Britain to Malaysia. 2. Noise reduction technology. A standout feature of the C949 is its innovative design aimed at significantly minimizing sonic booms. The aircraft is projected to emit a sonic boom at a perceived level of 83.9 decibels compared to the Concorde's 105 decibels. This reduction is achieved through a unique reverse-camber fuselage design that effectively reduces shockwave formation during flight. This advancement could potentially allow for overland supersonic travel, which has been restricted in many regions due to noise complaints. 3. Technological innovations. The C949 integrates advanced aerodynamic features, including a shape-shifting fuselage and an artificial intelligence-powered fly-by-wire system. These innovations are designed to provide enhanced stability and control, particularly during high-speed maneuvers. Competitive landscape. The announcement of the C949 places Comac in direct competition with several international projects aimed at revitalizing commercial supersonic air travel. Notable competitors include NASA and Lockheed Martin's X-59, as well as US-based startups like Boom Supersonic and Spike Aerospace. While Boom's XB-1 has already completed successful test flights, the C949 positions China as a formidable player in the evolving aerospace industry. Timeline of key events. March 14, 2025, Comac engineers publish an academic paper detailing the design and specifications of the C949 in the journal Acta Aeronautica Sinica. March 29 to 30, 2025, various media outlets report on the C949's features, emphasizing its potential impact on the future of aviation. Common key points across sources. The C949's extended range and noise reduction capabilities are highlighted as significant advancements over the Concorde. The innovative design aimed at minimizing sonic booms is consistently noted, showcasing Comac's commitment to addressing historical challenges in supersonic travel. The competitive context of other international supersonic projects is acknowledged, illustrating a renewed global interest in faster air travel. Differences between sources. Some articles delve deeper into the engineering challenges and technological aspects of the C949, while others emphasize the geopolitical implications of China's investment in supersonic technology amid rising international tensions. Variations in details concerning passenger capacity and specific design features appear across reports, indicating differing focuses among sources. Conclusion. The introduction of the C949 is poised to not only surpass the Concorde's legacy but also usher in a new era of aviation characterized by quieter, faster, and more efficient air travel. As Comac progresses with this ambitious project, global attention will remain focused on its implications for both commercial aviation and international relations within the aerospace sector. The C949 represents a significant leap forward in technology, potentially transforming the dynamics of air travel as we know it. As the aerospace community watches closely, the successful realization of the C949 could redefine the standards of passenger flight, enabling a future where supersonic travel becomes a commonplace and accepted mode of transportation. China's unveiling of the C949 Supersonic Jet by Comac challenges conventional notions about advancements in aviation technology and geopolitical dynamics. Here are several counterintuitive aspects of this development. 1. Speed versus range trade-off. While the C949 is designed to cruise at a maximum speed of 1.6 Mach, which is substantially slower than the Concorde's 2.2 Mach, it compensates for this reduction with a 50% increase in range, 11,000 kilometers compared to Concorde's 4,500 miles. This suggests that in the race for commercial aviation, range may have become a more critical factor for airlines than sheer speed, contradicting the traditional emphasis on speed in supersonic travel. 2. Noise reduction innovations. The C949's ability to reduce sonic booms to a perceived level of 83.9 decibels is significantly lower than the 105 decibels produced by the Concorde. This achievement allows for potential overland supersonic flights which were previously restricted due to noise complaints. It counterintuitively highlights that advancements in technology can lead to regulatory changes that were once viewed as barriers to innovation, indicating a shift in the regulatory landscape toward allowing supersonic travel. 3. Geopolitical implications. The development of the C949 does not merely reflect a technological ambition, it also signifies China's determination to assert itself in the aerospace sector traditionally dominated by Western companies. This counters the assumption that the US and its allies would continue to lead in aerospace innovation without significant competition from nations like China. The geopolitical implications of this race could lead to increased tensions, as nations may view advancements in aviation technology as potential military capabilities. For market viability and passenger capacity, the C949 is designed to accommodate 168 passengers, which is more than the Concorde's capacity of 128. This focus on higher passenger capacity indicates a counterintuitive approach to supersonic air travel, traditionally seen as a luxury service catering to elite customers. By targeting a broader market, Comac aims to make supersonic travel more accessible, challenging the perception that such innovations are solely for an affluent demographic. 5. AI and aerodynamics. The incorporation of an AI-powered fly-by-wire system and advanced aerodynamic features such as a shape-shifting fuselage suggest that the future of aviation may rely more on artificial intelligence and less on traditional mechanical systems. This shift could counter the conventional belief that pilots will always need direct control over aircraft, proposing instead a future where AI plays a critical role in flight operations, potentially enhancing safety and efficiency. 6. Environmental considerations. The push for quieter and potentially more environmentally friendly supersonic travel through technologies that minimize sonic booms challenges the long-standing narrative that supersonic jets are inherently detrimental to the environment. The advancements in noise reduction and aerodynamics may make supersonic travel more acceptable to regulatory bodies and the public, suggesting that environmental concerns may not be as prohibitive as previously thought. 7. Competition from diverse players. While Comac's C949 enters a competitive landscape with established players like NASA and Lockheed Martin as well as startups like Boom Supersonic, the notion that only established aerospace giants can succeed in this field is being challenged. The rapid development of new technologies and the increasing interest from various global players indicate a democratization of aerospace innovation, countering the belief that a few dominant companies will remain unchallenged. In conclusion, the unveiling of China's C949 Supersonic Jet represents a significant shift in aviation technology and market dynamics. It highlights a counterintuitive reconfiguration of priorities where range, noise reduction, and market accessibility may take precedence over traditional speed metrics, all while reshaping geopolitical landscapes in the process. The unveiling of China's next-generation supersonic jet, the C949, by the state-owned aerospace company Comac is a noteworthy development in the aviation industry. While many may focus on the jet's impressive specifications such as its speed range and noise reduction capabilities, there are several underlying aspects of this announcement that deserve closer examination for their broader implications. 1. Sonic boom mitigation and regulatory impact. One of the standout features of the C949 is its ability to significantly reduce sonic booms to a projected 83.9 decibels. A substantial improvement over Concorde's 105 decibels. This innovation, achieved through a unique reverse-camber fuselage design, aims to address one of the primary reasons for the Concorde's eventual retirement: community noise complaints and regulatory restrictions on overland supersonic flights. Significance: the reduction in sonic boom intensity not only paves the way for potential overland routes which were previously banned due to noise regulations, but it also sets a precedent for future aircraft design. If the C949 successfully demonstrates that supersonic travel can be both feasible and environmentally considerate, it could lead to a relaxation of regulations globally, opening new markets for supersonic travel and reshaping commercial aviation dynamics. 2. Geopolitical considerations. China's foray into supersonic technology, particularly with a project of this magnitude, reflects broader geopolitical ambitions. The C949 is positioned not only as a technological marvel but also as a strategic asset that could bolster China's influence in global aviation and technology sectors. Significance: the development of the C949 comes at a time of heightened international tensions, particularly with the United States. As other nations including the US invest in their own supersonic projects, China's entry into this race could be perceived as a challenge to US dominance in aerospace technology. This competition can have ramifications that extend beyond aviation, affecting trade relations, technological exchange, and international partnerships in various sectors. 3. Sustainable aviation goals. The C949's design emphasizes not just speed and capacity but also the integration of advanced technologies aimed at enhancing efficiency and sustainability. The use of artificial intelligence in its fly-by-wire system, for example, showcases a commitment to modernizing aircraft controls to enhance safety and performance. Significance: as the global aviation industry grapples with its environmental impact, the C949 represents a potential shift towards more sustainable aviation solutions. If Comac can successfully market the C949 as a greener alternative to traditional jetliners, it could lead to a significant transformation in passenger travel, influencing other manufacturers to adopt similar technologies. This aligns with the growing emphasis on sustainability across industries and could redefine consumer expectations regarding environmental responsibility in aviation. 4. Market dynamics and passenger demand. The projected passenger capacity of 168 for the C949 exceeds Concorde's 128 seat capacity, indicating a shift towards making supersonic travel more accessible to a broader audience. The aircraft's ability to cover distances of up to 11,000 kilometers also suggests that it could serve a wider range of international routes. Significance: the emphasis on passenger capacity suggests that Comac is not only focused on the prestige of supersonic travel but is also attentive to market demands for cost-effective and high-capacity travel solutions. If the C949 can attract a significant number of passengers, it could lead to a resurgence in demand for supersonic travel, prompting existing airlines and new entrants to consider incorporating supersonic options into their fleets. This will likely drive further innovation and competition within the aviation sector. 5. Technological innovation and global competition. The C949's advanced features, including its shape-shifting fuselage, are indicative of significant research and development investment by Comac. This technological edge positions China as a serious competitor to established aerospace giants in the US and Europe, such as NASA and Lockheed Martin. Significance: the global aerospace industry has historically been dominated by a few key players. However, China's advancements through projects like the C949 could disrupt this status quo. As Comac continues to innovate, it may encourage other nations to bolster their own aerospace programs, resulting in an accelerated pace of technological advancement across the industry. This could have long-term implications for global aviation, including increased collaboration and competition among nations. 6. Public perception and market readiness. Despite the technical advancements and ambitious goals of the C949, public perception and market readiness remain critical factors that could influence its success. The retirement of the Concorde was partly due to safety concerns and environmental issues, and these factors could still weigh heavily on consumer acceptance of a new supersonic jet. Significance: the public's response to the C949 will be a determining factor in its market viability. If Comac can effectively communicate the safety and environmental benefits of the C949 along with its technological advancements, it could alleviate concerns and foster interest in supersonic travel. Conversely, any negative public perception could hinder the project's success regardless of its technical prowess. Conclusion: the introduction of the C949 by Comac is a multifaceted development that extends beyond the realm of aviation technology. Its implications for regulatory changes, geopolitical dynamics, sustainability, market competition, and public perception are significant and warrant careful consideration. As the aerospace industry stands on the precipice of a new era in supersonic travel, the C949 could serve as a bellwether for future advancements and the evolution of global aviation. In-depth analysis of China's C949 Supersonic Jet Initiative. China's unveiling of the C949 Supersonic Jet represents a pivotal moment in the aerospace industry as it aims to revive commercial supersonic travel nearly 2 decades after the retirement of the Concorde. The C949 project, developed by Comac, is characterized by several innovative features and has significant implications for aviation and international relations. Here we identify 4 key points worthy of in-depth analysis and discussion. 1. Technological advancements and innovations. The C949 incorporates several groundbreaking technologies designed to enhance performance and reduce environmental impact. Speed and range. Although the C949's top speed of 1.6 Mach is lower than the Concorde's Mach 2.2, it compensates with an impressive range of 11,000 kilometers, approximately 6,800 miles, significantly surpassing the Concorde's 4,500 miles. This extended range allows for non-stop flights on long international routes, catering to a growing demand for faster air travel. Noise reduction technologies. One of the most notable advancements is the C949's ability to significantly reduce sonic booms. The projected noise level of 83.9 decibels achieved through a unique reverse-camber fuselage design makes it comparable to common household appliances, thus addressing one of the major regulatory hurdles that grounded the Concorde. This innovation could pave the way for overland supersonic travel, which has been restricted due to noise complaints. Aerodynamic features and AI integration. The aircraft includes a shape-shifting fuselage and an artificial intelligence-powered fly-by-wire system aimed at improving stability and control. These features represent a leap in aerodynamics and aircraft control systems, potentially setting new standards for future commercial jets. 2. Potential market impact and passenger capacity. The introduction of the C949 could significantly reshape the commercial aviation market. Increased capacity. With a passenger capacity of 168, the C949 exceeds the Concorde's 128-seat configuration, allowing airlines to operate more economically on high-demand routes. This increase in capacity, combined with supersonic speeds, could attract a new segment of travelers willing to pay a premium for reduced travel times. Market viability. The C949 is designed for mainstream viability, targeting an estimated 45 million annual passengers in the supersonic travel market. This projection indicates a robust potential market, suggesting that there is an appetite for faster, more efficient air travel that could revitalize interest in supersonic flights. Strategic positioning. By entering the supersonic market, China positions itself as a leader in aviation technology. which is not only economically beneficial but could also enhance its geopolitical presence in global aviation. This ambition is juxtaposed with initiatives from Western companies and agencies such as NASA's X-59, creating a competitive dynamic that could lead to further advancements in aviation technology. 3. Geopolitical implications and international competition. The C949 project is not just a technological endeavor, it has significant geopolitical implications. Aerospace rivalry. Comac's initiative signals China's intent to compete directly with established aerospace powers like the United States and Europe. This competition may spur innovation and accelerate the development of new technologies across the industry, leading to advancements that benefit consumers globally. Military considerations. There are concerns regarding the dual-use nature of supersonic technologies that can be adapted for military applications. As China enhances its aerospace capabilities, this raises questions about the implications for global military balances and the potential for technology transfer that could affect national security. Regulatory challenges in international relations. The development and deployment of the C949 will likely require navigating various international regulatory landscapes, particularly regarding noise and emissions standards. The success of the C949 may depend not only on technological advancements but also on China's ability to engage diplomatically with other nations to harmonize regulations and ensure market access. 4. Environmental considerations and future sustainability. As the aviation industry faces increasing scrutiny regarding its environmental impact, the C949 aims to address these concerns through innovative design. Sustainable aviation goals. With the C949's focus on reduced noise pollution, it reflects a growing recognition within the aerospace sector of the need to balance technological advancement with environmental sustainability. The reduced sonic boom allows for potential overland flights, which could alleviate congestion in air traffic and contribute to more efficient travel patterns. Long-term viability. The C949 is part of a broader trend towards developing environmentally friendly aviation technologies. As the industry evolves, innovations such as hybrid electric engines and sustainable fuels may become integral to future designs, echoing global sustainability goals. Public perception and acceptance. The success of the C949 will also depend on public perception regarding the environmental impact of supersonic travel. Engaging with communities and stakeholders to address concerns about noise and emissions will be crucial in gaining broader acceptance for the return of supersonic jets. Conclusion. The C949 Supersonic Jet initiative by Comac is a landmark project that embodies both technological innovation and significant geopolitical implications. By enhancing speed, range, and passenger capacity while addressing noise concerns, China aims to reshape the future of commercial aviation. As the global aerospace landscape becomes increasingly competitive, the successful development and deployment of the C949 could set the stage for a new era of air travel characterized by faster and more efficient planes that meet contemporary environmental standards. The ongoing developments in this sector will be closely watched, as they will not only influence commercial aviation but also reflect broader trends in international relations and technological advancement. Here are 3 famous historical cases that bear similarities to China's ambitious plans for a next-generation supersonic jet. 1. Concorde's development and operation 1960–2003. The Concorde, developed jointly by British and French aerospace engineers, was the first supersonic passenger airliner to enter service in 1976. Its development was marked by significant technological advancements in aerodynamics, engine design, and materials science. The Concorde could cruise at speeds of up to Mach 2.04, allowing it to fly from New York to London in under 3 hours. However, the Concorde faced numerous challenges, including high operating costs, strict noise regulations due to its sonic booms, and environmental concerns. Ultimately, it was retired in 2003 largely due to these operational challenges and the decline in demand for supersonic travel post 9/11. The legacy of the Concorde has inspired current projects like Comac C949, which aims to address some of the limitations that led to the Concorde's retirement. 2. NASA's X-15 program 1950s to 1960s. The X-15 was a rocket-powered aircraft developed by NASA and the U.S. Air Force to explore the boundaries of flight at the edge of space. With the ability to reach altitudes over 350,000 feet and speeds exceeding Mach 6, the program gathered significant data on aerodynamics, thermal protection, and human factors in high-speed flight. The technological innovations and data obtained from the X-15 program contributed to various aerospace advancements. Similarly, the C949 project aims to leverage cutting-edge technology to reduce sonic booms and enhance aerodynamics, just as the X-15 helped push the boundaries of what was possible in aviation. 3. SST Supersonic Transport Initiatives 1970s to 1980s. Various countries, including the United States with the Boeing 2707 and the Soviet Union with the Tupolev Tu-144, embarked on ambitious projects to develop their own supersonic transport aircraft during the 1970s. The Boeing 2707 was intended to be a technologically advanced supersonic airliner boasting innovations in fuel efficiency and passenger comfort. However, due to a combination of high development costs, changing market demands, and environmental concerns, the project was ultimately cancelled in 1971. The challenges faced by these initiatives resonate with modern efforts to revive supersonic travel, particularly regarding noise pollution and sustainability, which Comac addresses in its design for the C949. These historical cases illustrate the complexities and challenges associated with developing advanced aviation technologies, particularly in the realm of supersonic travel, which Comac seeks to navigate as it embarks on its C949 project. China's unveiling of the C949 Supersonic Jet by Comac represents a pivotal moment in the aviation industry, signaling a potential renaissance of commercial supersonic travel. With ambitious goals set for 2025, the C949 aims to outpace the now retired Concorde not only in speed but also in passenger capacity and noise reduction. Here's a closer look at the future outlook for the C949 and the broader implications for the aviation sector. Technological advancements. The C949 is designed to travel at speeds of up to 1.6 Mach with a range of 11,000 kilometers, approximately 6,800 miles. This significant enhancement over the Concorde's maximum range of 4,500 miles positions the C949 for long-haul international routes, such as non-stop flights from Shanghai to Los Angeles in approximately 5 hours. The aircraft's innovative reverse-camber fuselage aims to reduce sonic booms to a more acceptable level of 83.9 decibels, potentially allowing for overland flights that were previously restricted due to noise complaints. Competitive landscape. As Comac advances its C949 project, it enters a competitive field that includes significant players like NASA with its X-59 and U.S. startups such as Boom Supersonic and Spike Aerospace. The competition is not only about speed and range but also revolves around noise reduction technologies and market positioning. Comac's entry into this arena is a clear indication of China's aspirations to be a leader in aerospace technology, especially as the global demand for faster travel continues to grow. Market potential. The revival of supersonic travel could tap into a market of approximately 45 million annual passengers, representing about 1% of global air traffic. With the C949 targeting mainstream viability and comfort, it aims to attract business and leisure travelers looking for faster travel options. As airlines adapt to new technologies, we could see a gradual shift in consumer preferences towards supersonic travel, especially for long-distance routes. Environmental considerations. While the C949's technological innovations promise a quieter flight experience, environmental concerns over supersonic travel remain. The aviation industry faces immense pressure to reduce its carbon footprint, and the development of supersonic jets must align with global sustainability goals. Comac's ability to integrate environmentally friendly practices into the C949's operations will be crucial in gaining acceptance from regulators and the public alike. Geopolitical implications. The introduction of the C949 also holds geopolitical significance. By stepping into the supersonic race, China is not only positioning itself as a technological leader but is also enhancing its soft power in the global aviation market. This could lead to increased tensions with the US and its allies, particularly as concerns grow over the dual-use potential of aerospace technologies. As nations compete for leadership in aerospace innovation, we may witness a shift in global alliances and partnerships in the aviation sector. Future outlook. Looking ahead, the success of the C949 will depend on several factors. 1. Regulatory approvals. Overcoming regulatory hurdles related to noise and emissions will be essential. If Comac can demonstrate the C949's compliance with international aviation standards, it may facilitate quicker adoption among airlines. 2. Market adoption. The willingness of airlines to invest in new supersonic fleets will hinge on consumer demand and operational costs. Airlines will need to evaluate the financial viability of operating supersonic jets in a competitive market. 3. Technological evolution. Continuous innovations in aerospace technology, including advancements in materials aerodynamics and fuel efficiency, will shape the future of supersonic travel. The C949 will likely evolve based on lessons learned from initial models and competitive developments. 4. Global economic conditions. Economic factors including fuel prices and global travel demand will impact the profitability of supersonic airlines. A stable economic environment will be conducive to the growth of this sector. 5. Sustainability initiatives. As the aviation industry increasingly focuses on sustainability, Comac's ability to align the C949 with eco-friendly practices will be vital for its long-term success. Innovations in sustainable aviation fuel and emissions reduction technologies will play a significant role. Conclusion. China's C949 supersonic jet symbolizes a bold step towards the future of commercial aviation, promising faster, quieter, and more efficient travel. The project not only highlights China's technological ambitions but also sets the stage for intense competition in the aerospace industry. As developments unfold, the C949 could redefine global air travel, offering insights into the future of transportation while navigating the complexities of regulatory, environmental, and geopolitical landscapes.